Welcome everybody to this new lecture of our paper Electronic Communication System, and today we will continue our discussion over frequency demodulation. And in our previous lecture we were studying about the methods of frequency demodulation, and these are the methods which we are discussed in our previous lecture. That is this mechanism of frequency demodulation is mainly achieved by the two steps. First, the frequency modulated wave. Frequency modulated wave is converted into the amplitude modulated wave, and then use an envelope diode detector, and you can find the simple message or voice signal as you want to find or want to extract. Okay, and these are the methods. And because in our syllabus is included the Foster-Seeley discriminator or phase discriminator, but we can understand the working mechanism of this Foster-Seeley discriminator if we already know the working mechanism of slope detector and balanced slope detector. So in today's story, first we look at the working mechanism and arrangement of slope detector, and then we move forward to the balanced slope detector, and the demerits, when demerits of these two devices are overcome, then the new device which invented is known as Foster-Seeley discriminator. ओके और एलसी सर्किट के बारे में हम बात कर रहे थे कि एलसी सर्किट में किस तरह से एलसी सर्किट को हम रेजोनेंट सर्किट या टैंक सर्किट या फिर ट्यून्ड सर्किट कहते हैं, और इस तरह का कुछ फ्रीक्वेंसी रिस्पांस इस एलसी सर्किट का आता है, और ये मैकेनिक्स में या फिर कहीं एसी सर्किट्स में आपने ज़रूर स्टडी किया होगा किसी न किसी लेवल पे. सो पहले आज हम शुरू करने जा रहे हैं सिंपल स्लोप डिटेक्टर. लेट्स सी इट. This is the circuit diagram of simple slope detector. Okay, this. In this diagram, there are two blocks. This is the block. This is the first dotted block. This block has a diode, a capacitor C, a resistor R. And you are very familiar with this relation, with this type of arrangement, okay. And this arrangement is the arrangement of envelope diode detector to extract the original information from the amplitude modulated wave. This device or this arrangement is done to extract the information from amplitude modulated wave. Okay, and you are very familiar to this. This is very broadly using device, envelope diode detector, and very cheap best device. Okay, and the another block is this dotted block, and this block is introduced into this whole system because of the conversion of frequency modulated wave to the amplitude modulated wave. Frequency modulated wave to the amplitude modulated wave. And first we look at the action of this block, which is used to convert the frequency modulated wave to the amplitude modulated wave, and then output of this block is used as the input of this block. Okay, so let us first discuss about this block which is used to convert a frequency modulated wave to an amplitude modulated wave. Okay, look at this. So here we have an input voltage, which is a frequency modulated input or frequency modulated wave, you can say it. This is the primary of a transformer, which is this is a capacitor C. That's why, because this is the primary, that's why it is written as CP. And this is the coil of the primary coil of the transformation, and it is denoted as LP. Okay, and this is tuned by another coil that is secondary of the transformer, and which have inductance LS, and this capacitance LP. This is not LP, this is CP. This is CP. This is CP. This is CP. This is CP, the capacitor of the secondary. This is not CP, this is CS actually. This is CS, the capacitor of secondary. Okay, and we tuned the primary of the of this transformer. This is a transformer. We tuned the primary of this transformation of this transformer with FC, with frequency FC, which is the frequency of carrier wave frequency, you can say it. Okay, and the secondary of the transformer is tuned to resonant frequency, because there is the phenomena. This is the LC circuit. This is the LC circuit. There is also a resonance, the phenomena of resonance. So this circuit is tuned. That is, the secondary of the transformer is tuned to the resonant frequency, and the primary of the transformer is tuned to the carrier frequency. Okay, and the condition for conversion of frequency modulated wave to the amplitude modulated wave is this: when the resonant frequency is very, very greater than FC, then the frequency modulated wave is converted into the amplitude modulated wave. How it can be done? Look at this frequency response curve. Okay, this is the frequency response curve of this LC circuit. Okay, and here is on this axis, this is gain, and on this axis we are taking the frequency. Okay, and this is a modulated wave which is applied as the input, which is here, this V input, FM input. This is the frequency modulated wave, and we want to convert this frequency modulated wave into amplitude modulated wave. So how can we done this process? This is explained by this whole frequency response curve, or you can see it is gain versus frequency curve. So how it can be done? This is the frequency modulated wave. Okay, and this is the carrier frequency FC. This is FC plus delta F. The frequency is increasing in this side, and this is FC minus delta F. The frequency is decreasing in this side. Okay, so look at this curve. The frequency modulated, when a frequency modulated input is come to this, and this primary is tuned to FC. This primary of the transformer is tuned to FC, that is the carrier frequency. Then when the amplitude of the modulated wave is increasing, you can say it, the corresponding frequency of the wave is increasing, and this is the gain. This is the gain of corresponding to frequencies. The gain corresponding to the carrier frequency is G2. The gain corresponding to Fc plus delta F is Z1, and the gain corresponding to Fc minus delta F is Z3. Okay, look at here. When the amplitude of the signal or the modulated wave, FM modulated wave, which is used as the input of this circuit, when the amplitude of the frequency modulated wave, or you can say it as the frequency of frequency modulated wave is increasing, the gain of the transformer, the gain is also increasing. Look at there. When the frequency modulated wave at its peak amplitude and corresponding frequency is also peak, the gain is increasing. Look at this. At this point, gain is maximum. At this point, gain is maximum. And when it comes back to this point, the gain is equal to Z2 again. And when it going to the minimum value, the gain is decreasing. This is the gain is decreasing, and decreasing. Okay. So when the frequency is increasing, you can see it. When the frequency is increasing, the corresponding gain is also increasing. The corresponding gain is also increasing, and when the frequency is decreased, the corresponding gain is also decreased. And these are the relation between these gains. G1, the gain G1 is greater than G2 is greater than G3. Okay. This. So when you plot these gains into this axis, so look at here. Frequency increase, gain increase, and corresponding value of the amplitude or the modulating signal is increased. This amplitude modulating signal is increased. And when frequency is at its maximum, the gain is at its maximum, and the amplitude, the corresponding amplitude is at its maximum. When gain becomes zero, when frequency is at Fc, that is the frequency of this primary coil, is equal to this primary coil, the gain is equals to G2, and the corresponding amplitude is equals to 0. Or you can say it as intermediate way. And when the frequency is on the decreasing side, this frequency is on the decreasing side, the gain is decreased and corresponding amplitude of the signal is also decreased. Okay, so in this way, a frequency modulated wave by this gain factor is converted into the amplitude modulated wave. And because amplitude modulated wave has this signal and the frequency, the carrier frequency also, when this output of this circuit, when the output of this circuit is using as the input of this circuit, so because this is the amplitude modulated wave now, the frequency modulated wave by the gain factor is converted into the amplitude modulated wave, and amplitude modulated wave consists this signal and also the frequency component, the carrier wave, because we want only the information sending from the transmitter. So when this is used as the input of this block using as the envelope diode detector, so the frequency component or the carrier component, these components are extracted or removed from this, and we are left with this original signal. Okay, and this can be done by this envelope diode detector, and V output, which is a modulating signal, we can get it by this type of arrangement, and this type of arrangement is known as simple slope detector. This arrangement is known as simple slope detector. There are some shortcomings or drawbacks for using this detector, and that are non-linear characteristic of gain. This is the non-linearity characteristics. This actually the ideal gain should be a straight line. gain versus amplitude or gain versus frequency graph should be a straight line. But here is the low non-linear characteristic of gain, which results into some extractions of masses. Okay? Which results into exact extractions of masses. And second is, it is very difficult to tune the primary and secondary of the transformer to different frequency, that is FC and FR. ये भी एक चैलेंज है इसमें कि हमें एक ही ट्रांसफॉर्मर की प्राइमरी को अलग फ्रीक्वेंसी पे ट्यून करना है और सेकेंडरी को अलग फ्रीक्वेंसी पे ट्यून करना है और इस कंडीशन के साथ फिर परफॉर्म करना है, दैट FR is very greater than FC. To extract the information or to convert the frequency modulated wave into an amplitude modulated wave. Okay? एक तो ये डिफिकल्टी है कि इसको जो प्राइमरी कोइल है आपको इसको FC पे ये फ्रीक्वेंसी है जो करियर फ्रीक्वेंसी उस पर ट्यून कीजिए और जो सेकेंडरी है उसको रेजोनेंट फ्रीक्वेंसी पे ट्यून कीजिए. डिफिकल्ट है, दिस सीम्स टू बी डिफिकल्ट. ओके. एंड एक नॉन लीनियरिटी जो गेन में है वो भी एक इसका ड्रॉबैक्स सामने आया और तब हमने डिज़ाइन किया इन ओवरकम्स को, इन शॉर्टकमिंग्स को दूर किया और फिर हमने डिज़ाइन किया बैलेंस्ड स्लोप डिटेक्टर. दिस balanced slope detector. This is the circuit diagram of balanced slope detector. You can see it. There are again two blocks. The first block is this. Actually, there are three blocks. The first block is this block. This block is used to convert the frequency modulating signal to the amplitude modulating signal. This block, this, and this block, the upper block, this is the envelope diode detector, but this is the first component of envelope detector, this, and the same detector, envelope diode detector 2, is this. So the balanced slope detector have three blocks. The working mechanism of first block is to convert the frequency modulated wave to the amplitude modulated wave, and this diode detector is convert to the amplitude modulated wave and giving as the input of this block of this diode and giving to the corresponding output, and this is also do the same function. Okay, when you give the amplitude modulated wave as the input of this whole block, which is acting or work as the envelope diode detector, so the output of this block will also be a modulating output. Okay, so let's see it. First, look at the difference between the simple slope detector circuit and the balanced slope detector circuit. Look at here. That is the frequency modulated wave is input to the primary of this transformer, to the primary, which is tuned to the frequency FC. That is okay. Now same here, from here or till here is the same as the function of simple slope detector. But look at here. Look at here. This is the transformer. This is the primary of the transformer. This is the secondary of the transformer. Okay. So look at here. The secondary of the transformer is divided into two components. This is the center tapping. This is the center tapping. This, and this gives rise to the or affected to the output of these two diodes, and by the center tapping, the upper portion is this coil is named as L1, the capacitor is named as C1, LC circuit, LC circuit, LC circuit. So, and this is the transformer T1 say, and this is again by the center tapping. This inductor is named as L2, the capacitor is named as C2, and this transformer is named as T2. This part is tuned to the frequency Fc minus delta F, and the upper part is tuned to the frequency Fc plus delta F. So actually in balanced slope detector there are many things which is modified in the circuit of simple slope detector. In balanced slope detector there are 3 LC circuit now. First LC circuit, this, second LC circuit, this, third LC circuit, this. Okay, and these all 3 LC circuit are tuned to different frequencies. This first LC circuit is tuned to the carrier frequency. This circuit, the upper circuit is tuned, or you can say it as T1. The circuit T1 is tuned to the frequency Fc plus delta F, and this lower circuit is tuned to the frequency Fc minus delta F. Okay, and the output of this whole circuit is an amplitude modulated wave, which is fed as the input of this envelope diode detector, and which convert that into the modulating signal, or extract the modulating signal from the amplitude modulated wave. That is the function of envelope diode detector. Okay, so the balanced slope detector consists of 2 simple slope detectors, the first, second, as described above in balanced configuration. Okay, this eliminates the distortion present in single tune discriminator or the simple slope detector. तो डिस्टोर्शन का जो फंक्शन आ रहा था, डिस्टोर्टेड हो रही थी जो आउटपुट, उसको प्रिवेंट करने के लिए हमने इस तरह का ये अरेंजमेंट यूज किया. 2 सिंपल स्लोप डिटेक्टर को, सर्किट को हमने कुछ ऐसा बनाया जिसमें जो एनवेलप डायोड डिटेक्टर एक बैलेंस्ड कॉन्फ़िगरेशन में यूज किए गए, और इसी कारण इसका नाम पड़ा बैलेंस्ड slope detector. Okay, 2 simple slope detector is used in balanced configuration. That's why it is known as balanced slope detector. वर्किंग मैकेनिज्म के ऊपर बात कर लेते हैं. वर्किंग मैकेनिज्म कैसे, आपको मैंने ट्यूनिंग बता दी कि ये जो प्राइमरी ऑफ द ट्रांसफॉर्मर है ये ट्यून्ड किया गया है एक फ्रीक्वेंसी Fc पे. ये जो अपर पार्ट ऑफ दिस सेकेंडरी इज known as this function, or this part is known as T1. T1 is tuning to Fc plus delta F, and T2 is tuning to Fc minus delta F. Okay, so look at the working mechanism of this. So primary tank circuit TP, this is tuned at frequency Fc, okay, which is the carrier frequency, and secondary tank circuit, this is divided into 2 circuits, the T1 circuit and the T2 circuit. The T1 circuit is the upper half, T2 circuit is the lower half. The T1 circuit tuned at Fc plus delta F, and the T2 circuit is tuned at Fc plus delta F. Okay, so the first case, when incoming signal frequency F is equals to Fc, जब इस जो इनकम जो फ्रीक्वेंसी मॉड्यूलेटेड वेव है उसकी इनकमिंग फ्रीक्वेंसी को मैंने F यहाँ कंसीडर किया है, वो बराबर हो Fc के, तो क्या होगा? Then induced a voltage V in the tank circuit T1, also induced a voltage V in the tank circuit T2. तो यहाँ जो वोल्टेज होगी वो वोल्टेज T1 में भी वही वोल्टेज होगा और T2 में भी वही वोल्टेज होगा, बिकॉज ये फ्रीक्वेंसी F इज इक्वल्स टू Fc की वजह से. ओके, सो डायोड के अक्रॉस जो वोल्टेज जाएगा, डायोड के अक्रॉस जो वोल्टेज, क्योंकि डायोड D1 का जो इनपुट आएगा वो इस इस सर्किट से आएगा, T1 सर्किट से आएगा, और डायोड T2 का जो इनपुट आएगा वो इस सर्किट से आएगा, T2 से आएगा। और चूंकि F इक्वल टू FC है, यानी जो इनकमिंग फ्रीक्वेंसी मॉड्यूलेटेड वेव है उसकी जो फ्रीक्वेंसी है वो कैरियर फ्रीक्वेंसी के बराबर है, इसलिए जो इंड्यूस्ड वोल्टेज होगा यहाँ इस सर्किट में वो भी वोल्टेज V होगा, और जो इंड्यूस्ड वोल्टेज होगा यहाँ वो भी V ही होगा। चूंकि ये वोल्टेज इनपुट का काम करता है डायोड D1 का, और इस टैंक का वोल्टेज जो T2 का टैंक का वोल्टेज है वो इनपुट करता है डायोड D2 का काम, तो जो डायोड D1 के अक्रॉस वोल्टेज होगा वो VD1 होगा, और वो बराबर होना चाहिए VD2 के। क्यों? क्योंकि जो इंड्यूस्ड वोल्टेज यहाँ है टैंक T1 में वो V है, और वही वोल्टेज यहाँ है, तो जो वोल्टेज यहाँ डायोड D1 के अक्रॉस जाएगा वही वोल्टेज डायोड D2 के अक्रॉस होगा। So VD1 should be equals to VD2. That is the voltage of diode D1 should be equals to voltage of diode D2. Okay. Now जब यहाँ से वोल्टेज वही पास हुआ तो यहाँ जो इस रजिस्टर R1 के अक्रॉस जो वोल्टेज आएगा वो ही वोल्टेज आएगा वो इस रजिस्टर R2 के अक्रॉस। That means the voltage, the magnitude of the voltage across R1 should be equal to the voltage magnitude of the voltage across R2, and say this voltage V is equals to V. Okay, so hence the output voltage. What is the output voltage? What is the output voltage? V out is equals to VR1 minus VR2. Why VR1 minus VR2? Because diode D1 and diode D2 is out of phase. This polarity is out of phase to each other. If this conduct, this will not conduct. If this conduct, this will not conduct. Okay, so the output voltage because of opposite polarity is VR1 minus VR2. This minus sign is coming out of because of that factor. So because VR1 is equals to V and VR2 is equals to V, that is equals to 0. That is nothing at the output of the balanced slope detector. When the incoming signal frequency is equals to the carrier frequency, which is the tuning frequency of this primary coil. This. So nothing is at the output of the balanced slope detector. Okay. Now discussed the second case. Discussed about the second case when FC is in between the frequency, the incoming frequency, and the frequency of the frequency modulated wave, the frequency of the frequency modulated wave is in between FC and FC plus delta F. This यानी मैक्सिमम फ्रीक्वेंसी से और जो कैरियर फ्रीक्वेंसी है, जब जो इनकमिंग सिग्नल की फ्रीक्वेंसी जब इन दोनों फ्रीक्वेंसी के बीच में हो, तो जो इंड्यूस्ड टैंक का वोल्टेज है यानी T1 का जो वोल्टेज है शुड बी ग्रेटर देन द इंड्यूस्ड वोल्टेज इन टैंक T2. क्यों? क्योंकि जो फ्रीक्वेंसी है ये FC इज लेस देन F एंड F इज लेस देन FC प्लस डेल्टा F. तो यहां फ्रीक्वेंसी ज्यादा होगा तो कोरोस्पोंडिंग वोल्टेज भी ज्यादा होगा. और इस सर्किट को देखिए, इस सर्किट को देखिए, यहाँ फ्रीक्वेंसी की ये किस फ्रीक्वेंसी पे ट्यून्ड है? T1 सर्किट FC प्लस डेल्टा F. और ये किस फ्रीक्वेंसी पे ट्यून्ड है? सर्किट T2, ये है FC माइनस डेल्टा F. तो जहाँ फ्रीक्वेंसी ज्यादा होगा वोल्टेज भी वही इंड्यूस्ड जो वोल्टेज होगा वो वहाँ भी वही ज्यादा होगा. हेंस द इंड्यूस्ड वोल्टेज इन टैंक T1 बिकॉज ऑफ लार्जर फ्रीक्वेंसी इज ग्रेटर देन द इंड्यूस्ड वोल्टेज इन टैंक T2. This. That is, the voltage across diode 1 should be greater than voltage across diode 2, and the voltage across, the magnitude of the voltage across resistor R1 should be greater than the voltage, magnitude of the voltage across resistor R2. This VR1, magnitude of VR1 should be greater than the magnitude of VR2. Hence the output voltage. is V out, VR1 minus VR2, and because VR1 is greater than VR2, so V output should be greater than 0. That is, we have a positive voltage there. That is, we have output through the balanced slope detector, and this value is equal to the V max, that is the maximum voltage appeared when the frequency of the incoming frequency modulated wave is in between the carrier frequency and this frequency, which is the tuned frequency of tank T1. And moving to the third case, when the frequency F of the incoming frequency modulated wave, which is used as the input of that block, and which is in between the Fc minus delta F and Fc, then induced voltage in tank T1 should be less than the induced voltage at tank T2. Why? Because अब जो incoming वेव की फ्रीक्वेंसी है वो Fc माइनस डेल्टा एफ से कम है, और Fc माइनस डेल्टा एफ किसकी फ्रीक्वेंसी है? Fc माइनस डेल्टा एफ इस टैंक की फ्रीक्वेंसी है T2 की। तो फ्रीक्वेंसी जो इनकमिंग वेव की है वो इस फ्रीक्वेंसी से कम है, इस फ्रीक्वेंसी से कम है। तो इसका मतलब जो वोल्टेज यहाँ डेवलप होगा इस फ्रीक्वेंसी के साथ, जो इंड्यूस्ड होगा वोल्टेज, वो ग्रेटर होगा इस वोल्टेज से। Okay, so induced voltage at tank T1 should be less than the induced voltage at tank T2, or the voltage across diode D1 should be less than the voltage across diode D2, and the magnitude of the voltage across resistor R1 should be less than the magnitude of the voltage across resistor R2. Hence the output voltage. So output voltage is equal to VR1 minus VR2. Because VR1 is less than VR2, then we can say that there is a negative voltage, and that voltage is the V minimum. This voltage is V. So far we have three cases. The first case is that when the incoming frequency F is equal to Fc, there is no voltage at the output. When incoming frequency F is in between Fc and Fc plus delta F, there is a maximum voltage at the output. And when the incoming frequency F is in between Fc minus delta F and Fc, there is minimum voltage at the output of balanced slope detector. Okay, this is the frequency response curve of the balanced slope detector, because we have two tanks here, the response curve of T1, and this is the response curve of T2. Okay, and this is the actually V out versus frequency curve. This is the central frequency or carrier frequency Fc. This is Fc plus delta H, that is the frequency is increasing in this side, and in this side frequency is decreasing. Okay, so look, try to understand the first case. When F equal to Fc, the incoming frequency is equal to Fc. So when the Fc this, then there is a point here. There is a point here, that is V out is 0 at frequency Fc. Okay, and when frequency, look at the second case, when frequency is between Fc plus delta F and Fc. So there is some point between Fc and Fc plus delta F. There is some point between these two frequency, Fc plus delta F and Fc, because this frequency, incoming frequency, is in between these two frequencies. So let us say this point is this. And on the frequency response curve of T1, there is this point, and corresponding point on this frequency response curve is here. So this voltage is V maximum. This voltage is corresponding to V maximum. This voltage corresponding to this point. And when the frequency is in between the fc minus delta f and fc, that is here, this point. So there is a point on this frequency response curve of T2, and there is a point on this frequency response curve of T1, and which is corresponding to Vmax. And this point, and this point is corresponding to V voltage minimum. And look at the locus of these points. This point, this point, this point, this point, and this point, this point, this point, and this point. So you have a S-type characteristic or S-type shaped characteristics as we obtain from the output of balanced slope detector. So this is the working mechanism of a simple balanced slope detector. And what are the drawbacks? What are the drawbacks of a simple slope detector? And the drawbacks are these. These are the drawbacks. First is, though linearity is in balanced slope modulator is better than that of simple slope detector, but is still not good. हालांकि यहाँ linearity कुछ आई है, यहाँ इस response curve को देखिए, इस response curve को देखिए, यहाँ से लेकर यहाँ से और यहाँ तक का ये जो curve है ये लगभग linear है. तो linearity तो आई है, but जो linearity destroy होती है वो इन points पे जाके फिर से linearity क्या हो जाती है, destroy हो जाती है. So linearity आई है, लेकिन अभी भी उस लेवल की linearity नहीं है जिसको हम आइडियल स्लोप कहें. सेकेंड, नो एम्पलीट्यूड लिमिटिंग इज प्रोवाइडेड. कोई लिमिटिंग एम्पलीट्यूड पे कोई लिमिटिंग प्रोवाइड नहीं की है जिससे कि नॉइज का फैक्टर डिस्टॉर्टेड होती है आउटपुट और नॉइज का फैक्टर वहाँ आता है. जब तक एम्पलीट्यूड लिमिटर हम यूज नहीं करेंगे तो नॉइज का फैक्टर वहाँ से एम्पलीट्यूड मॉड्यूलेटेड वेव से नहीं जाएगा, यानी एक कांस्टेंट एम्पलीट्यूड की वेव मुझे नहीं मिलेगी. तो नो एम्पलीट्यूड लिमिटिंग इज यूज्ड हियर. एंड द थर्ड इज ट्यूनिंग ऑफ ट्रांसफॉर्मर कॉइल टू 3 डिफरेंट फ्रीक्वेंसीज is very difficult. This is the most important demerit of or more or a merit which have to be more concentrated that these there are three tank circuit which tune to 3 different frequencies, which is very, very difficult work. This, the primary is tuned to FC, the tank T1 is tuned to FC plus delta F, and tank T2 is tuned to FC minus delta F. This is very, very difficult work. This is very, very difficult work. Tuned to the 3 tank circuit to 3 different frequencies is very difficult. So linearity is improved, but still is not very good. Second, no amplitude limiter is used. That's why distortion in the amplitude voltage, output voltage, and there is the function of noise. And the third is to tune the 3 tank circuit to the 3 different frequencies is very difficult. So by limiting these shortcomings, the Foster-Sillett discriminator is coming into our study, and this eliminates all of these drawbacks, and a new discriminator known as phase discriminator is coming into our study. Okay, so that's all for now, and meet you into the next one. Thank you.